Next is Just the Basics, Climate Change and Policy. Each session will have a Just the Basics session, just to recap and review some pertinent points. Dr. Corey Bills will be introducing the first section. Dr. Corey Bills is faculty at the University of Colorado in the Department of Emergency Medicine and a core member of the Global Health Care Initiative and current Global Health Fellowship Director. Previously, he was assistant professor at the University of California, San Francisco, and affiliate faculty member of the Institute for Global Health Sciences. Dr. Bills graduated medical school and attended residency in emergency medicine at the University of Chicago, where he served as chief resident. He subsequently completed a global health fellowship and was a clinical instructor at Stanford University before joining the faculty at the University of California, San Francisco. He obtained a master's in public health from Columbia University as a Peter J. Sharp Scholar and worked for several years with the International Rescue Committee on Refugee Youth and Adolescent Programming. Dr. Bills has previously partnered with multiple government and other non-governmental organizations, including the World Health Organization, Pan American Health Organization, Human Rights Watch, the Clinton Foundation, CARE International, United Nations Special Representative for Refugee Youth, and Amnesty International. Dr. Bills' current global health work focuses on methods of assessing quality in the development of acute care referral and pre-hospital systems in resource-limited settings, with particular focus in Liberia and Uganda, as well as India. I've highlighted a few of his articles and work here. He has published extensively Reducing Early Infant Mortality in India, particularly as it pertains to emergency medical service. He's published on global health education, working to better teach our upcoming leaders on international collaboration and cooperation.
Hi everyone, this is Dr. Corey Bills again. I'm going to be talking about key events and terms in climate change history, otherwise known as Just the Basics here. And the main reason is really to make sure that we're all on the same page in understanding what the history of climate change is, both from a scientific standpoint and also from a policy standpoint. So we're going to provide a brief timeline of important events in climate change, while at the same time providing a quick overview of about 8 terms that are used throughout these lectures and which there are agreed upon definitions for that I think are important to kind of understand. So why focus on history at all? And I think one of the main reasons is because we seem to be repeating ourselves over and over again. About 100 years ago in 1926, there was this article published on smallpox and climate in the American Journal of Public Health, which really made the connection for one of the first times between an epidemic and climate. And what they recognized, partially given the fact that there wasn't a lot of data at that time, was that, quote, among the influences which we have been inclined to neglect is climate. And what they're really saying is that they've neglected climate as a risk factor for population health, and in this case, for smallpox in particular. It's interesting because today now we see the same threat and the same relationship being drawn out in the literature as well. This article, The Climate Crisis and COVID, a Major Threat to the Pandemic Response, was published in the New England Journal of Medicine, making the connection between the two tragedies in September of last month. Interestingly, even the same way in which we kind of reference pandemics or epidemics by the use of the Grim Reaper hasn't really changed at all either. There was a previous pictorial of the Grim Reaper, which was representing smallpox on the previous slide. So given kind of this relationship between now and the past, let's take a step back and just go through some of the high points of climate change history. So let's begin in 1896. Arrhenius constructed the first climate model of the influence of atmospheric carbon dioxide, calculating warming from carbon dioxide levels or making the correlation between warming and carbon dioxide. This idea between changes in climate to astronomical factors affecting the amount of solar energy or heat received at the Earth's surface was made by a mathematician, Serbian mathematician named Milankovitch, in a paper entitled The Mathematical Climatology and the Astronomical Theory of Climate Change. Skip ahead to 1960, 30 years later, and Keeling, a scientist, began to track atmospheric carbon dioxide concentrations at the Earth's surface. The curve that he developed is a graph of the accumulation of carbon dioxide in the Earth's atmosphere and is based on continuous measurements taken at the Mauna Loa Observatory on the island of Hawaii. It began in 1958 and it continues to present day. And while there's seasonal variation, and you can see in the graph, within the graph, that there's a rise or the largest amount of CO2 tends to occur in May, with the lowest amount of CO2 tending to occur in September, the year-to-year trend clearly shows an abrupt and consistent rise in carbon dioxide concentrations. And so when you couple that with overall warming trends over the same time period, you start to see the correlation between the two. Based on this science, policymakers, especially at the international level, started to take note. And in 1979, the first World Climate Conference was held in Geneva and sponsored by the WMO. It was one of the first major international meetings on climate change and was essentially a scientific conference. It was attended by scientists from a wide range of disciplines. This then led to the first session of the UNEP Intergovernmental Panel on Climate Change, or IPCC, in Geneva. The IPCC was created to provide policymakers with regular scientific assessments on climate change, its implications and potential future risks, as well as to put forward adaptation and mitigation options. Both of those terms I'll define a little bit later. It had a working group structure and set a timeline for reports. Its first report in 1990 noted a pattern of past warming while signaling future warming being likely. And in 2001, the third IPCC report noted warming from greenhouse gas emissions or concentrations. And in 2007, the fourth IPCC report noted the effects of global warming as occurring. There were several other IPCC reports, but I just kind of referenced three here just for the sake of brevity. In 1992, the UN conference in Rio, in Brazil, established a framework on climate change, tasked with establishing greenhouse gas concentrations. This then led to the Kyoto Protocol, which was created with the intent to limit greenhouse concentrations. And in 2005, after several years of negotiation, it finally went into effect. The Kyoto Protocol contains legally binding commitments, and it was signed by 193 countries to reduce anthropogenic greenhouse gas emissions, including from carbon dioxide, methane, perfluorocarbons, and others, to at least 5% below 1990 levels in the first commitment period. So that was between 2008 and 2012. There was a period at which the Kyoto Protocol was to be ratified, but they couldn't come to an agreement, and so that's what set forth the Paris Agreement. The Paris Agreement, initially agreed upon in 2015 and then signed in 2016, sought to deal with greenhouse gas emissions, mitigation, adaptation, and financed, and sought to keep the increase in global average temperature to well below 2 degrees Celsius, above pre-industrial levels. So this is kind of a quick overview of the timeline of both science and policy as it relates to climate change, and hopefully gives you a general idea of where we've been and where we are right now. So just so that we're all on the same page, I also want to just clarify a few terms as they relate to climate change. So the first is quite broad, but refers to climate. And climate, in a narrow sense, is usually defined as the average weather, or more rigorously as the statistical description in terms of the mean and variability of relevant quantities over a period of time. Whereas climate change refers to a change in the state of the climate over, say, that same time period. Relating to this is global warming. And global warming is the estimated increase in global mean surface temperature averaged over a 30-year period, or the 30-year period centered on a particular year or decade. The relationship between global warming and climate change is also related to rise in carbon dioxide. And carbon dioxide is thought, though while a naturally occurring gas, as the principal anthropogenic greenhouse gas affecting rising temperatures or changes in climate. The next set of terms really are related to how we think about how climate change affects health. So the first is adaptation. Adaptation is the process of adjustment to actual or expected climate and its effects in order to moderate harm or exploit beneficial opportunities. Exposure is the presence of people, livelihoods, species, ecosystems, environmental functions, services, and resources, or economic, social, or cultural assets in places and settings that could be adversely affected. Those exposures are related to hazards, and hazards are the potential occurrence of a natural or human-induced physical event or trend that may cause loss of life, injury, or other health impacts. So this includes things like flood, temperature rising, changes in crop yields. Mitigation is our ability or human abilities to reduce emissions or enhance the sinks of greenhouse gases, whereas vulnerability is the degree to which a system is susceptible to or unable to cope with the adverse events or effects of climate change, including climate variability and extremes. And this encompasses a variety of concepts and elements, including sensitivity, susceptibility to harm, or lack of capacity to cope and adapt. So hopefully, in referencing the brief overview of the history of climate change, we have a better sense of where we are today. And by giving a brief overview as well of the common terms that climate change scientists and policymakers use, we can move forward through the rest of these talks with an agreed upon idea of what these terms mean and what the historical importance of climate change is. If you have any questions or comments, you can email me here, and I hope to hear from some of you in future sessions. Thank you.